Space travel is expensive, arduous, and dangerous, and yet we seem determined to send humans into space and back to the moon. Even when we have so many problems here on Earth that need our attention, like war, poverty, and climate change. For some, though, the reason behind why is easy.
We as humans are inherently explorers, that we are just sort of programmed to go beyond, and push the frontiers. And I think to some extent that's true of humans. If you look at human history, especially deep human history, right? We know that our species first evolved in Africa, and it has expanded to occupy nearly every habitable speck of land on our planet. And now we're expanding beyond that. So in some ways, it seems like a continuation of what, we have been doing for literally millions of years.
That's Scott Solomon, teaching professor of biosciences at Rice University and author of Becoming Martian: How Living in Space Will Change Our Bodies and Minds. His interest in space travel took root early, influenced by shows like Star Trek and films like Star Wars.
So I saw Project Hail Mary recently, and that was so much fun. And I even wrote an article kind of trying to tie that back to what's happening now with Artemis, because no spoilers here, because people might not have seen Project Hail Mary. But, at its heart, it's about following a person on a space mission, on a dangerous and sort of high probability of failure kind of mission. And I think that is at the heart of why we're so enamored with the Artemis 2 mission, right? Why it's different when we send people to space versus when we send a rover to Mars. Like, it's super cool when we send a rover to Mars, don't get me wrong. But you don't have that same emotional connection to a robot as you do to people. And especially when we're able to talk to those people and hear them describing the experience they're having.
Like many of us, Solomon was glued to the NASA live stream, following everything the astronauts were doing and saying, including when something as simple as the toilet on the Artemis 2 wouldn't work.
This is something that is a little bit different actually for the Artemis 2 mission, because compared to the Apollo missions that went to the moon back in the 60s and 70s, the big innovation in the toilet department is that there is one. So the Apollo astronauts did not have a toilet per se. They basically had to attach a device to themselves that would just hold on to their waste, and then liquid waste could be basically ejected from the spacecraft. For the Artemis 2 mission, they have a actual area on the spacecraft, on the Orion spacecraft, where they can kind of go into a private area, and there is actually a toilet facility. And so that was actually something that, interestingly, they had some issues with during this mission, because the urine line actually got frozen at one point, and they had to reorient the spacecraft slightly so that the sun was hitting that portion of the spacecraft so that it would thaw it out.
And it's details like these that highlight a bigger reality. Living in space isn't just about rockets and landings. It's about the day-to-day basics, which brings up a crucial point. How do you manage basic hygiene in space? How do the astronauts take a shower?
They basically wipe themselves down with wet wipes. That's the main kind of way that they can maintain personal hygiene. Yeah, and that's similar to what the Apollo astronauts have done, and also what astronauts do on the International Space Station. So you can't, take a shower. You can't immerse yourself in liquid. Sometimes astronauts describe it as being kind of like a prolonged camping trip or something like that, right? But yeah, even on a camping trip, sometimes you can go jump in a lake or something like that. So it's one of the challenges.
Another challenge of prolonged spaceflight is the psychological and physical strain of living in a tight, enclosed space for days on end.
If it's just for a few days, sure, you can manage. But if we're starting to think about longer experiences, like having a moon base, right? How big is the space that you're going to have? How much privacy do you have? You can't easily just go for a walk if you need to go kind of get away and get some fresh air and recharge your batteries. So those are real issues.
While in orbit, the Artemis 2 crew described flares that indicated meteorites hitting the moon's surface. In fact, meteorites hit the moon's surface all of the time. How can astronauts possibly build a settlement on the moon when its surface is constantly bombarded?
That's one of the risks and one of the challenges. And one of the reasons why building infrastructure underground, or at least protected by lunar regolith, is a good idea. You have a couple of issues. You've got the impacts of meteorites, which are constantly hitting the moon. I mean, they're hitting Earth too, but as you said, we have an atmosphere that helps to kind of burn them up. So they have to be quite large for them to still have enough mass when they reach the surface to cause much damage. And then the other issue is radiation exposure, because the atmosphere on Earth helps to block some of that radiation. The other thing that we have on Earth that the moon doesn't have is a magnetic field that also blocks radiation. So the moon has neither of those things, and it makes the radiation exposures much more extreme.
Scientists wonder if they can genetically alter human biology to withstand greater amounts of radiation to survive in space over long periods of time. And that question has pushed researchers to look at some of the most extreme life forms on Earth. To test this theory, they sent a microscopic animal called a tardigrade, also known as a water bear, into space. Tardigrades are found worldwide and live in aquatic and semi-aquatic habitats, such as lichen and damp moss. They can withstand high amounts of radiation and pressure.
They look like gummy bears with like a little nozzle for a nose. I think they're adorable. But they have been brought up into space and exposed to the vacuum of space and space radiation and survived. Some researchers have figured out some of the genetic basis for how they're able to do that, and then taken those genes and put them into human cells in a lab, in a petri dish. But those human cells then had a greater ability to tolerate radiation exposure after they had received those genes. So at least in theory, we could do more of that type of thing and basically equip people living in space, on Mars, wherever, with the ability to better tolerate those conditions.
Even though living off-planet may be hundreds of years into the future, Solomon and many researchers know we need all that time to prepare. Our bodies have evolved and adapted to the Earth's environment. Everything from our hormones to blood circulation is driven by Earth's gravity, magnetic field, and so much more.
There's a lot of our biology that we don't even think about how tied it is to being on planet Earth. I mean, even just like the Artemis 2 astronauts right now, one of the challenges that they have is there's no day-night. Right? I mean, you're out in space. The sun's not rising and setting. And so, they have to kind of create that daily cycle, and mission control helps them create it. They can turn the lights on and off. I was just listening as they were playing their morning wake up song, which is great, but like, okay, they're going for 10 days. What happens if you're there for years or your entire life, right? And, the conditions on other planets like Mars are different in some ways, right? And our biology is tied to that. The ways in which our hormones are kind of expressed and how that influences our mood and our biology and things like our metabolism and our immune system, it's tied in with those daily cycles, with those annual cycles. And all that would change if we were living, especially for multiple generations, in a place that had completely different cycles and different conditions.
And that's where the conversation starts to shift from what's possible to what's acceptable. Even if we had the technology to alter human cells to make them radiation resistant, should we? We'll explore these questions and more next week. Solomon's book, Becoming Martian: How Living in Space Will Change Our Bodies and Minds, is available now online and in select bookstores. To find out more about our guests this week, visit viewpointsradio.org. For more behind the scenes, follow us at Viewpoints Radio on Instagram, X, and Facebook. This segment was written and produced by Polly Hansen. Our executive producer is Amira Zaveri. Our studio manager is Jay Silvers. I'm Marty Peterson.